All right, we're going to do the notes for 5.6. We're going to solve both logarithmic and some more exponential equations. There's a strategy up above here that I do want to go through because really when you're talking about logarithmic equations, they're going to come in two different forms. One you will solve one way and another one you'll solve another way. So here are the following two ways. If you can get the log statement alone on one side and have it equal to a value c, then you're going to solve it one way. That way is going to be using your definition. The other way is if I can get two single log statements on both sides, and then you'll remember the property that said if I have the log base a of something equals the log base a of something, then you just take the two somethings and you set them equal to one another. So number 2 says, of course, if you can get it into this form, then you just change it to its exponential, a to the c equals x, and you solve. Or again, if you get it into this form, then you just take the two somethings and you set them equal to one another. And then you want to make sure, you don't have to full out check your equations, but you just want to make sure that you're not trying to take the log of a negative number, because that is not included in the domain, because by our definition, our x always has to be greater than 0. Okay, so we'll see all of these in effect when we do our equations here. So if we look at example 1a, you can see that you've got logs on both sides. So we're going to use number 3 from above. Now the first thing that you want to do though is you want to use some properties, and you have to remember that this 2 was really an exponent. So we could write that right hand side as the log base 3 of x squared. So see, now we have the log base 3 of something equals the log base 3 of something else. So now you just take the two somethings and you set them equal to one another. So if I square root both sides, I'm going to get plus and minus 2. But we're going to throw out the negative, because if I plug in negative 2 back into the right-hand side, I'd be finding the log of a negative number, which is not in our domain. So the only answer for this one is x equals 2. So that's using number 3 from above, that strategy. Now, notice for B, we've got all the logs on one side. So what we're going to do is we're going to use strategy number 2. We're going to condense these into a single log. And hopefully you remember that we did a problem where if I've got two logs that are being added, two individual logs, that means originally those two expressions were being multiplied. So it would look something like that. Remember, if this was a subtraction, then it would be division. So now let's go ahead and multiply these out. So we would get log base 2. If I were to FOIL these out, let's see, I'm going to have x negative x squared, 2, and minus 2x. And then if I go ahead and if I combine my like terms, I'm going to have negative x squared, let's see, minus x plus 2 is equal to 1. Let's make sure that that's right. Minus x. Okay, so now since I have the single log statement on this side, I'm going to use my definition, change it to its related exponential. I would do that by taking 2 to the first power, which is simply 2, and setting that equal to negative x squared minus x plus 2. Now I'm going to solve this. So I am going to bring everything over to the left. So my x squared is positive. I have a quadratic. So x squared plus x. And then if I bring over the 2, that's going to cancel out. So it'd be x squared plus x is equal to 0. I can factor that by factoring out the x. So I would have two solutions, maybe. I would have x equals 0 and x equals -1. Now let's make sure that those both work. If I plug a 0 either into here or here, am I taking the log of a negative number? No. If I plug a -1 in, am I good? I'm also good. So for this equation, there are actually two solutions. Okay, so number 2, we're doing the same thing. We're following these, we're solving these equations. By the way, notice they're called log equations. Why? Because the word log is in them. That's why they're not exponential equations. So I've got kind of logs all over the place, but if I were to put these two logs together by using my property, and again, because the two individual logs are being added, I'm going to multiply. This would become the natural log of x times x minus 1 equals the natural log of x plus 2. So remembering that natural log really just means log base e, I have the log of something is equal to the log of something else. So I'm going to go ahead and I'm going to set the two parts equal to one another. So I just distribute it over here. Again, I have a quadratic, so x squared minus 2x minus 2 is equal to 0. And I think you can probably try to factor that, but it's not going to factor. It happens. So you can use your quadratic formula. I'm going to choose to use completing the square, which is something that you did in 113. So, but again, quadratic formula would give you the exact same answer. So let me just quick do completing the square. I'll kind of explain it as I go. So you get the incomplete square alone. Now we're going to complete this square by adding 1 here, which means I have to add 1 over here. If I factor this, I'm going to get x minus 1 quantity squared equals 3. If I square root both sides, I'm going to get x minus 1 equals plus and minus the square root of 3. And if I simply add 1, I have two answers, 1 plus and minus the square root of 3. Now, if I take 1 minus the square root of 3, and if I did that on my calculator, I'd end up with a negative number. So, because I can't find the log of a negative number, I need to toss that solution. So my only solution is 1 plus the square root of 3. That's the exact solution. Of course, you can put it into your calculator to find an approximate solution. Okay, let's look at B. So again, I see that here, this one, all my logs are on this side. So I'm just going to condense this side into a single log. Now, because this is subtraction, that means that originally they were divided. So I'm going to make this h plus 3 over 2 minus h. Now, since my logs are all on one side, I use my definition 4 to the first power is equal to h plus 3 over 2 minus h, and I'm going to solve by cross multiplying. So if I go this way, I'm going to get 8 minus 4h equals h plus 3. If I move things around, I'm going to get negative 5h equals negative 5. So h is equal to 1. And I look, and there's no way that I could plug a 1 in and be taking the log of a negative number. So there's one solution to this equation, and it is 1. All right. Let's do this one up here. So these are going to be a little bit more difficult. So see here you have logs on either side, but the problem is this 1. And we can't connect those or combine those because this is not a log statement. So what we want to do for this one is I want to bring this log over to the left side. So it'll be the log of 1 minus c minus the log of 1 plus c is equal to 1. Now I have all my logs on one side, so I'm going to condense these two together. Subtraction means they were originally divided. Now remember, since there's no base here, it's understood to be a 10. It's a common log. So now I use my definition, 10 to the first power, which is 10, is equal to 1 minus c over 1 plus c. Again, I'm going to cross multiply. So I'm going to get 10 plus 10c equals 1 minus c. If I move things around, I'm going to get 11c equals negative 9, which means c is negative 9 over 11. Now, if I plug in negative 9 over 11 to both of these spots in the original equation, am I going to be taking the log of a negative number? I am not. So there's one solution. We're going to do something similar for D. Notice D, we're looking at natural logs, but we're going to kind of use the same steps here. So I'm going to move this guy to the left-hand side by subtracting it. Now I'm going to condense this to a single log. Now, remember, what is the base of a natural log? It's actually e. So if I use my definition, it would be e squared is equal to 3m plus 1 over m minus 3. And I believe your book is going to ask you for the exact answer, so we don't want to plug in e squared into the calculator and get a value because we would be rounding. So let's just go ahead and cross multiply. This is going to take a little bit more work here. So if I go this way, I'm going to get 3m plus 1 equals me squared minus 3e squared. Now I'm solving for m, so I need to get everything with an m to one side. So it would be 3m minus me squared equals negative 1 minus 3e squared. I need to factor out the m here. We've done a problem like this before. So that would be 3 minus e squared So if I divide both sides by 3 minus e squared, those are going to cancel, and I'm running down here. So m is going to be equal to negative 1 minus 3e squared over 3 minus e squared. So we left it in its exact form with the e. Okay, I'm going to stop this video and continue it in another video.